Hi, and welcome to Geeks for Geeks. We would be discussing the problem known as maximum sum without adjacents. So, this problem is a variation of a very standard problem of dynamic programming. So, let's just discuss this. So, here in this problem, you are given an array itself. The array is something like 5, 5, 10, 100, 10, and 5 itself. This is what is given here. Now it is told that so you need to select the subsequence. What do you mean by subsequence? Subsequence is nothing but selecting elements from between, but they should be in the same ordering as they appear. And that subsequence should be the maximum out of this. Okay. So there is one more constraint to remember, that is the numbers shouldn't be adjacent. That is, if you see 500 and then again 5, which is equal to 110. This is the very first solution to the problem. Let's see the second test case, that is 3, 3, 2, 7, and 10. If you observe here, we need to focus on 10 and we can keep a focus on 3 and the output would be 13. But if you observe this thing, this focus thing, this is the catch here. The problem is that you saw number 3 and 2, you thought that I should take 3. Then you saw the number 2 and 7, you thought I should take 7. But if you take 7, you would lose 10. Same goes for here. If you see here, you would find that here 5 and 10. If you focus on the bigger number, it might be a scenario that if you compare 5 and 10, the bigger number is 10, and selecting 10 seems to be a profitable trade. But if you select 10, then you would lose this 100, which is much more. So it might happen that if you compare two things and you take the bigger one, then selecting that bigger one and adjacent of that bigger one would have a very bigger value, which is very profitable. So this would cause all the confusion. So if you just, what is the very first thing? That if I want to increase the total sum, if I want to increase the total sum, I would focus on large elements. This is the very simplest approach you can think of. If I focus on large element, then I might lose the larger element. Okay. So you would come to the conclusion that there is no proper way to just select a way or to select all the numbers which would be maximum. Like एक certain way नहीं है, क्योंकि आप ऐसा हो सकता है अगर आप स्मॉल वाला सिलेक्ट करो तो ऐसा भी हो सकता है एंड में जाके यहाँ पर 1 ही रहे 100 के जगह. If you select, let's say, instead of selecting the large elements, you start selecting the smaller elements. It might be true for some cases, but let's say this is 1 itself. So then you would get 5, then you would get 1, and from here you would get just 5, which is not a profitable trade. You could have made up 10, 10, and then again 5. What I meant to say is, instead of, let's say, you told Siddharth, if we can't select the larger element, I would select the smaller element. So if you select, if let's say this element, if let's say instead of here, this is 1, and you would say that I would select the smaller element. So you would select this, you would select this out of this, you would select this. And the cost would be 5 plus 1 plus 5, that is equals to 11. But the correct solution is 10, 10, and 5, which is equals to 25. So if you focus on the big elements, there would be some test cases to fail you. If you select smaller element, there would also be some test case to fail you. So there is no certain way to select the elements. So if so what we do in real life, let's take a very simple real life. Though if you have read Robert, so if I don't know how many of you have read, but how many of you, so if you are from a ICSE background, you would have read the poem by Robert Frost, The Road Not Taken. So here you are lost in the woods and there are two paths and you can't really find a way to select either of the path. So in real life, the way is to select is that way to select path is that you travel both the path and whichever is better, you would select that. So we would do the same thing here. If there is no certain way of find maximum subsequence, if there is no certain way, we would find all possible subsequence and we would return the maximum sum out of those. Fair enough. So whenever we come to the conclusion that we need to explore all possible ways, explore all possible is nothing, but it we need to conclude that this problem is of recursion. जब भी ये कहा जाए कि सब कुछ करके देखो, तब ये प्रॉब्लम है रिकर्शन का. So now let us do this. So how would we do this? Let's just see here. 3, 2, 7, 10. Let's start from the very first index. So for the very first index, we have two options. Either to include that in our solution or to not include that in our solution. This is take, this is not take. This is for the first index. Let's talk about the second index. The very first option is take 2. So if you take 2 after 3, this is not possible. So you can't really take 2 after 3. So you need to move forward and you need to ignore that is not take. So both would be 3 and here you have not taken 3, so you can take 2 or not take 2 because you are free to do that. Taking a particular index is a provision if you have not selected the last index. You can write a statement here. Next, you can just do an operation from this. So now, if I have not selected the last one, so I can select 7, that would make it 3, 7. I can ignore 7. If I have selected 2, I don't have any option but to ignore 7. Okay. Now, after doing this, let's talk about the last index. So if you have taken 7, there is no provision to take 10. So we can't really take 10. We can ignore 10. That would make it just 3 and 7. If we have taken 3, then if we have taken 3, we have no provision. If we have ignored 7 in the last step, ignored the 7, so now you can take 10, 3 and 10. If we have just taken 2, so you can always take 10. So these are the probable options. The very first one is 3 and 7. Next one is 3 and 10. The next one is 2 and 10. These are the 3 options out of this. The answer would be the maximum out of this, that is 13. That is this. So the answer is 13. So this is how you would proceed. Okay. So there is two options for us, that is take or not take, and you would move down. So if you have solved up at coder DP contest, and that is frog jump, you would get a hint of this problem. There are many problems to this, and the major take not take is used in 01 knapsack. Take or not take comes into picture by 01 knapsack. So I would suggest you to solve that. Now if you observe that based on recursion, so recursion would be would give you a very high time complexity, and if you like write a larger test case, you would see that there are overlapping things, like we are computing the same thing for again, so we would need to memoize it. Now let's memoize it directly. First we would write the recursive, and then we would just memoize it, and that would solve the purpose. So what we would do is we would write the recursive. So I would write recursive int recursive. So we have the index int I, we have the index, and then we have the given array, that is int arr. Instead of int arr, I would just write a, because I'm a very lazy person. Okay, int arr, and so we just need the index at each point. So if we have reached the very end, that is very start of that, we would return that. So if there is only one index, that is if I is equals to 0, we would return a of I. Okay. If by chance we have reached this position, that is if it is less than 0. So if there are less than 1 elements, then we can't do anything, but the answer would be 0. So if I is less than 0, so if we have only one element, we would just return that element. If we have no elements, the answer would be 0. These are the two base cases. Okay, done. Now comes the part when we would take this. So if we take the element, if we take that element, the value, we would add that value in our answer, that is a of I, and we would move to the I minus 2th index, because we can't really go to the next index. We would go to the I minus 2th index. So rec of what? I minus 2th index, and then a again. So you had observed now, if I have selected 3, I can't go to the next index, that is 2. I need to go to the next of next index, because if I have taken 3, I can't really go to 2. That is why I minus 2. If I have not taken, int not take is equals to, I can't add up this value in my answer, but I can select the next index. That is, I have ignored this property. So if I have ignored 2, then I can add up 7 in my answer. So that would be I minus 1. That would be I minus 1 comma a. Done. Then the maximum of take and non-take would be my answer. So int answer is equals to max of take comma not take, and return the value of the answer, and that is done. Okay, so I is equals to n minus 1 comma a. Let's just compile and see how many errors are we making. My output is correct, but if you submit this, you would see an error. You would see a TLE, time limit exceeded. Why? Because at each step, this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2. So the time complexity of this approach is 2 to the power n. So we need to optimize over this. Optimizing over this is, I told you that many a times we are doing the same computation again. So let's take up this example. So let's take, this is me. I went up and saw a friend of mine named as Manish. I saw that his traits doesn't match with me. So I ignored him and tried to find some other person who would match, whose traits would match with me. But then I again wasted my time on Manish. So if I had remembered that Manish does not have traits like me, the next time I wouldn't have wasted my time on Manish to make friends with him. So in the same manner, if I don't want to repeat the same mistake, I need to remember my mistake. So in life, if I don't want to repeat the same mistakes, I need to remember my mistakes or the lessons learned from it. We would do the same thing here. So recursion is a very simple person. He repeats the same mistake again and again. So if I make recursion remember that this is the mistake that you have already done, and if I store it, then this would be problem. This would be easy. So now what I would do is I would declare a vector of int dp or memo. Let's say memo of size n with everything as -1. -1 would just tell me that this position is still not tried. That let's say Ankit, I have not been a friend with Ankit. Manish, I have not been a friend with Manish. So if that value is -1, that means I have not been a friend of him. This is done. Now I would pass this memo. Now, before becoming a friend, I would check that memo of I. If that value is not equal to -1, that means I have already done friendship with him. Then I would just return the learning of my friendship from that point. I won't be friends. I won't again try to be friends with him. If I have already been a friend of him, I would just return the lesson. If I have not been a friend, then only these all statements should execute. And at the end, whatever lessons I have learned, I need to store that. Memo of I is equals to answer. Just before returning, I need to write it down in a pen and paper. Okay, and this is done. We need to pass this memo function by reference because I need to retain the values. Vector int and memo. Max of take not take. Here also I need to write memo. Here also I need to write memo. Just passing it again and again. And this should be good enough. I forgot to write the return function here. Let's just see. Now let us just submit this and see how many errors have we got. And yes, we are able to solve up this problem. So I just missed the return thing. So if you were able to learn something out of it, if you saw something that needs to be appreciated or saw something that needs to be inculcated, then positive criticism is always acceptable and appreciation would make me happier. That's it for today. If you are watching this stream in the recorded version, feel free to like and comment on the video so that the reach of this video could be increased. That's it for today. Thank you and have a nice day.